So now continuation from the 145 problem. So here, since the axis appears to be inclined to VP, so now in the second position top view, when the slant triangular face is to rest on HP, so the axis will be inclined to HP. So once the axis is inclined to HP, so obviously that axis will be in apparent length. Now, since the axis appears to be inclined, so naturally he has given in the problem as appears to be inclined. So it is the apparent length, apparent inclination what he has given. So we need to rewrite the same sketch on that 45-degree line, because since the axis here also it is in apparent length, so the inclination given is also apparent inclination. So from the projections of lines, always on the apparent inclination we will going to get the apparent length. So consider any point on the xy line and then draw a line inclined at 45 degrees to xy. Then with O as center, take a radius of O to O1 by using the compass. From O, you cut an arc on that 45-degree line to get this point O1. Then you transfer all the other points on this by considering the reference of O1. So you measure the length from O to A. From O, cut an arc on this 45-degree line to get the point A. Similarly, by using the compass, you measure the distance from O to this point. So from O, you mark that point. Then, since from this point, this line BE is perpendicular to O1, so from this point, by using the protractor, you measure an angle of 90 degree with respect to O1 and then draw a perpendicular line here. Then measure the distance from this point to E and also measure the distance from this point to B. Both will have equal distances. Similarly, from here with this as center, cut an arc on this side to get this point E. And similarly from this point, you cut an arc on this side to get the point B. Similarly, now once you extend this line O1 further with O as center, take a radius of O to this point. From O, you mark this point here on this O1 extended line. Then, since this line is perpendicular to O1 extended line, so you take by using the protractor. You measure an angle of 90 degree with respect to O1 extended line, and then you measure the length by using the compass from this point to C and also from this point to D. So both will going to have the similar distances. So from here you cut an arc on this side to get the point D, and also from this side you cut an arc on this side to get the point C. So once you get these points, then transfer all the lines from here to here, including the visible and invisible edges, as the same view. Then once you get this, now we have to write the front view of this. Then draw a vertical projector from O dash to the xy line and draw a horizontal projector from O dash, which will be on the xy line. So next, draw a vertical projector from C to the xy line, both from C and D to the xy line. Similarly, draw a horizontal projector from C dash and D dash, which is on the xy line, to get this point C dash and D dash. Similarly, you draw a horizontal projector from O1 dash and draw a vertical projector from O1 to intersect at the point O1 dash. Similarly, draw a vertical projector from B dash E dash and draw a horizontal projector from B dash E dash and draw a vertical projector from E to intersect at the point E dash. Then B to intersect at the point B dash. Then similarly, you draw a horizontal projector from A dash and draw a vertical projector from A to intersect at the point A dash. Then once you get this, name them. Then join A dash to B dash, B dash to C dash, C dash to D dash, D dash to E dash, and D dash to A dash, all with continuous thin lines. Similarly, join between O dash to A dash, O dash to B dash, O dash to C dash, O dash to D dash, and O dash to E dash, and then join the center line O dash to O1 dash with a center line mark. Once you get this, now we are going to apply the visibility and invisibility criteria. So here all the exterior edges of the boundaries of the solids are visible, So O dash to D dash, D dash to E dash, E dash to A dash, and A dash to O dash, and A dash to B dash, both will going to lie on the same line to get it on the boundary. So once you, now when you look from the front view, A, B, C, D, E is nearer to the observer. That is also quite evident from here. So once you look from the front view, A, B, C, D, E is nearer to the observer. So entire base is visible. So here O is on this side, O1 is on this side. So the triangular face OCD will be on the HP. So since it is near to the observer, so the entire pentagonal surface is visible. So you dark between B dash to C dash. So only the left out portion is O dash E dash. Since B dash C dash is visible, so O dash E dash will become invisible. And mark the center line of O to O dash to O1 dash. Since the entire pentagonal surface A dash, B dash, C dash, D dash and E dash is visible, so naturally O1 dash is also becomes visible. So now the final solution, the final solution will look like this. This is what it has to be written in the examination. So we are going to counter check whether our problem is right or wrong. So a pentagonal pyramid of 25 mm side and an axis length of 50 mm rests on one of its slant triangular faces on HP. Rests on one of the slant triangular faces on HP. Draw its projections when the axis appears to be inclined to VP at 45 degrees. Since we have satisfied all the conditions, and hence our problem is right.